All right, everybody, we are going to go through the study guide for tomorrow's Unit 2 test. I'm going to go through this as quickly as I can because there's a lot to cover on this. So if you have questions on this, because I'm going to be going through it so quickly, make sure that you bring them to class tomorrow. We can answer those questions before the test and be on our way. All right, so here we go. For number 1, we have v to the third times v to the sixth. Since we are multiplying with the same bases, you can add the exponents to get v to the ninth. It is not 2v to the ninth, it is v to the ninth. For number 2, 6 to the 8th over 6 squared. All you have to do, because we have a division problem here, you're going to take 6 to the 8 minus 2. You just subtract them. Do not divide 6 divided by 6. All you're going to have here then is 6 to the 6th power. Okay. For number 3, multiply what you can. So I believe the way that I taught you was 4 times 5, and then the u to the third times u to the 12th. Okay. Yeah. So we're going to add our exponents here. 4 times 5 is 20. U to the 3 plus 12 is u to the 15th. Okay. For number 4, any number to the 0 power is 1. So what this is either 1, b to the 15th, or just b to the 15th. Either of those are correct. That knocks out 1 through 4. Number 5, you have to distribute the outside 5 with all of the exponents on the inside. Remember that 5 to the first power is there, so you're going to take 5. Essentially what this would look like is 5 to the first raised to the 5th power times 5, c to the third raised to the 5th power. 1 times 5 is 5, so this will be 5 to the 5th power. 3 times 5 is 15, so this will be c to the 15th power. Okay? Number 6. 6 is an interesting one because looking at 6, none of these have the same bases, so we can't divide them. There's only one thing that we can do on 6, and it involves this -2. In the notes, I said use the reciprocal of whatever exponent has that -2. So since -2 is the exponent on the bottom, -2 needs to come on up to the top. So what this could either look like is 12n squared p squared over 1, or it could just be 12n squared p squared. That's all you have to do. You just have to use that negative right there to kind of flip that term that has the negative exponent. Okay. Number 7. All of this is multiplication, so I'm going to regroup these. A to the 8th, a to the, this is a first power there. This would be b to the second, b to the 0. Any term to the 0 power is 1, but we still have these same bases, so I am going to add them because we're multiplying them. So 8 plus 1 is 9, and 2 plus 0 is just 2. Okay, so you can still add those exponents even though that b to the 0 power is just 1. You're just going to be stuck with b squared. That's it. Number 8, since we cannot simplify inside the parentheses, you need to essentially distribute your exponents inside to the one on the outside. So this is r to the 7th squared over u to the 6th squared, which can be simplified to r to the 14th over u to the 12th. And that takes care of the exponent stuff. All right, that takes care of the exponent stuff on his study guide. All right. Okay, moving on. Number 9, in 2013, the Los Angeles Dodgers opening day payroll was about 2.16 times 10 to the 8th, and the Houston Astros was 2.4 times 10 to the 7th. How much higher was the Dodgers payroll? So what we're going to do is we're going to take Dodgers minus the Astros. You can do, and I'll tell you this now, I'll tell you this for each of these problems. You can do these in scientific notation. You can also do them in standard form. It doesn't matter to me. I think I'm going to go ahead and do them in scientific notation just because it can we can practice a little bit more with this. So the Dodgers is 2.16 times 10 to the 8th. Minus the Astros, which was 2.4 times 10 to the 7th. What I'm going to do is I'm going to increase the 7 by 1 because we have to have the same exponents if we are adding or subtracting. By me adding that 1, I have to decrease my decimal on that 2.4. So this will be 2.16 times 10 to the 8th minus 0.24 times 10 to the 8th. And this is going to work because I have my exponents of 10 the same, which is essentially like us lining up those decimals. So I'm going to subtract the first two terms, get 2.16 minus 0.24 to get 1.92 times 10 to that same exponent of 8. All right. It doesn't say what form we have to put this in, so I would take this. This would also be acceptable if you had 192. I believe that that's right, 192 million. Okay, $192 million. So that's what I have for number 9. For number 10, the TV show had 3.5 times 10 to the 8th viewers for their first episode and 8.5 times 10 to the 6th viewers for their second episode. How many viewers did they have overall? So how many did they have overall tells me we are adding. So I am going to just add these. Again, you can do this in scientific notation or standard form. I'm going to do scientific notation. The order does not matter. So I'm going to take 3.5 times 10 to the 8th plus 8.5 times 10 to the 6th. Just like I did on the last problem, I'm going to increase my exponent because I have to get them to be the same. It's essentially like we're lining up decimals to add or subtract. So this is going to be 3.5 times 10 to the 8th plus, I have to do this. If I'm increasing by 2 on my exponent of 10, I have to decrease by 2 down here. So this will be, let me move this, 0.085 times 10 to the 8th, okay? Add your first two terms, and this is going to be 3.5 plus 0.085, and I got 3.585 times 10 to the 8th. How many viewers did they have overall? It does not tell me what to write this in, so I'm going to do it both ways here. So 3.585, 2, 3, 4, 5. I believe that is correct. So 358,500,000 viewers. Okay, make sure we label those. That's what we got. All right, number 11. How many times larger? Stop right there. How many times larger means we are going to do division. Okay. How many times larger is the first term compared to the second term? So I'm going to take this 13,500 number divided by 1.5 times 10 to the third. And I'm actually going to rewrite these in this one because the denominator here is not a terribly difficult number to convert into standard form. I'm going to keep these in standard form. 1.5 times 10 to the third is 1, 2, 3. So it's 1,500, 1,500. And then I'm going to divide. And I get 9. So how many times larger? Is 9 times larger? Right, your answer in standard form, which is 9. In scientific notation, it would just be 9 times 10. 9 times 10 to the 0 is what it would be. So yeah, that's all we got there. I believe the last one here. An airplane traveled 5.7 times 10 squared miles per hour for 1.4 times 10 to the first hours. How far did the airplane travel? Write your answer in scientific notation. I had to reread this one because I was like, what are we doing? So here's what I'm thinking. We're looking for the distance, right? So something is going to equal the distance. What we have is we're going to take the speed times the time. So this is actually going to be a multiplication problem. Okay, this one was somewhat difficult just because of that, but I mean, think about it kind of like in a car. If you're driving, I don't know, 30 miles per hour for 1 hour, what math would you do to figure out how far you have gone in that time? So we're going to take speed times time and get our distance. So this is multiplication. This is your speed. Whoops. This is your speed. So we're going to take 5.7 times 10 squared times the time, which is 1.4 times 10 to the first hours. So 1.4 times 10 to the first hours is going to equal our distance. Since this is multiplication, we are just going to rearrange these so we get our 5.7 times 1.4 into one parenthesis, and then the 10 squared times 10 to the first into the other parenthesis. And you can add these exponents and just multiply in the other one. So we've got 5.7 times 1.4, which gets me 7. I'm going to write this over here. 7.98, which is between 1 and 10. That's good. Times 2 plus 1, which is 10 to the third power. And I would say this is going to be in miles because we're looking for a distance. And it wants us to write it in scientific notation, which I have done right there. Okay. There we go. That's the first page. Second page. When the moon is between the earth and sun, the distance from earth to its moon is 2.389 times 10 to the fifth. I might write that here. So earth to the moon is going to be 2.389 times 10 to the fifth power. That's that distance there. The distance from the Earth's moon to the sun is 9.3 times 10 to the seventh. So 9.3 times 10 to the seventh. Find the distance between the Earth and the sun. So what we are looking for is this right here. So this is going to be, I think we're just adding up the distance from the Earth to the moon and the moon to the sun. That's what I'm going to do. I think this is an addition problem. So I'm going to take my Earth, or the moon, sorry, Earth to moon distance. And I'm going to add that to the Earth's moon to the sun, which is 9.3 times 10 to the seventh power. Just like we've done in past addition problems here, I'm going to increase this 5 by 2. which means I have to decrease my decimal by 2. Now, 0.2389 times 10 to the 7th plus 9.3 times 10 to the 7th. We can add these up now. I know that my sum here is going to end up with something times 10 to the 7th. So I'm going to take the 0.2389 plus 9.3 to get 9.5389, which that does work. That is between 1 and 10, so that will work in scientific notation. It does say write your answer in scientific notation, so make sure that we are keeping track of that. This is in miles. It's a distance, so it's in miles. Labeling that is kind of nice as well. Okay. All right, number 14, select all the expressions that are equivalent to x to the third times x to the fifth. Okay. I'm just going to kind of show my work to the side here. Before I even look at my answers, I want to make sure that I do this right. So x to the third times x to the negative fifth. We want to simplify this and see how else we could write it. Since I have the same base and I'm multiplying between these, you can add the exponents. So I'm going to take 3 plus negative 5, which would get me x to the negative second power. So I'm going to look around here. A seems to work, but you should know from the notes and from me getting on your guys' cases about it, we can simplify negative exponents. So what we need to do is make this into a fraction and flip it. So this is 1 over x squared, which is conveniently enough right here. We cannot simplify that anymore. That's it. That's all we got. Okay. Number 15, fill in a number to make the statement true. This one, don't make this harder than it needs to be. 4 plus what number would get us a sum of 10? Because our rule says that if we have the same base and we are multiplying, we can add those exponents. So 4 plus what gets us 10, and that is going to be 6. So we will put 6 in there for that variable x. Okay, so there we go. Or if you want, you could write it like this. I mean, it does say x equals, so let's do that. But on a test, what I'll do is if you write like z to the 6th power, I would count that as well. That's correct. Okay. All right. Plot the following numbers on a number line. So we did deal with these a little bit in terms of like estimating. These are rational numbers. So what I would do is I would probably just use a calculator on these. I'm going to kind of not estimate, approximate. I'm going to approximate these a little bit because I think that's going to help me plot these on this number line. So let me give the about sign right there. And so square root of 20, if you want, you can put that into a calculator, but it does fall between two perfect squares, 25 and 16. My calculator says this is about 4.47. Pi is about 3.14. We've known that for a while. That number is actually already, we can approximate it, maybe cut it off there, something like that. We'll have an easy time with that one. And then the opposite of the square root of 5. So what I'm going to do is take the square root of 5, take the opposite of it, which is about, let me do this, about negative 2.24. Okay, so I have all of those. I think in terms of plotting these, because it's going to get really messy if we use all of them, I might assign, which you absolutely can do, I'm going to assign them letters. So we'll call him A, B, C, D. So A, 4.47, that's close to 4.5. I'm going to plot A right there. B is about 3.14, so it'll be close to 3, but it will be not exactly on 3. So this is going to be B right here. C is 2.3, so that's between 2 and 3, and it's closer to 2. So somewhere like that. And D was the opposite of about 2.2. So it's going to be a negative, and it will be between -2 and -3. Maybe somewhere around there. These are just estimations. They're approximations. Do your best on this. Okay. Number 17. Which of the following is closest to point F? So that would be this one right here. It looks like it's going to be between 3 and 4. Square root of 7 is 2.6, so this is about 2.6, so it's not A. B is 1 and 5/7, so that's going to be between 1 and 2, so it's not going to be B as well. Square root of 15 is between two perfect squares of 16 and 9. It's leaning more towards 16, which would be 4. So this is, this is the one right here. C. It's about, and I can kind of show this. This is going to be about 3.87. Is it exactly where F is? No, it's not. But it is the closest. It's the closest to point F. So we will go with C on that one. 35% is 0.35 or 3500. So that's not even larger than 1. So we will not use that one. Estimate the value of 3 times the square root of 10. The square root of 10 is awfully close to the square root of 9, which is a perfect square. So if we take 3 times 3, we would get about 9. Okay. You could also just type that into your calculator, which is 9.486. But I'm estimating that's what the problem says to do, so that's what I will do. Kind of find my perfect squares around that one. Fill in the blank. We need to kind of make this inequality true here. Is it going to be greater than, less than, or equal to? I kind of want to estimate. I'll use a calculator to check, but my closest perfect square to 15 is 16, which is like square root of 16 is 4. So 2 times 4 gets me 8. 6 is close to the perfect square. It's between the perfect squares of 4 and 9, closer to 4. So I would say this would be like 3 square root of 4, which is about 3 times square root of 4 is 2, which is 6. So I am going to say that 8 is greater than 6. So this will be A. I'm going to use my calculator to type or to double check myself here. So this is about 7.75. 3 square root of 6 is about 7.35. So it's actually closer than I expected, just with my estimations. But it is still true. 2 square root of 5 is greater than 3 to the 6th power. Or sorry, 3 times the square root of 6. I got exponents on the mind. That takes care of number 2. Let's go ahead and do the next. The next page. This is it. How many square roots does 49 have? Explain. Hopefully, you guys are using your notes on these because it does explain when we deal with square roots, typically how many square roots each perfect square has. 49 has 2. 49, let's see here. 49 has, I swear, has 2 square roots. Obviously, what number times itself is going to be 49? Obviously, positive 7. Do this. Positive 7 is going to get you 7 times 7 equals 49. But also, what other number times itself will get you a positive 49? That's going to be negative 7. Okay, so negative 7 times negative 7 will also get you positive 49. Okay, so it doesn't say explain. My math is not good enough to be an explanation. So let's think about this. 49 has two square roots, positive 7 and negative 7. Why does that work? Because both um, positive and negative 7 result in a product. Product is the answer to a multiplication problem of 49. Okay, and that is the definition of a square root. Which two numbers can you multiply together to get a product of something? So in this case, that'll work. 49 has two square roots, positive 7 and negative 7. Both positive and negative 7 result in a product of 49. That works. And we can prove that with the math. Okay, so now my explanation follows that math that I showed. Okay. 21, between which two whole numbers, there should be an S there, nice typo, is square root of 40 located on a number line? I'm actually going to show you my estimation here. So square root of 40, between which two perfect squares is the square root of 40? The smaller of the perfect squares is going to be 36. Larger square root of 40 perfect square is going to be 49. Square root of 36 is 6. Square root of 49 is 7. A seems to be our winner on that one. Okay. That's 21. Yeah, that's 21. 22. Select all of the following solutions to the equation. If we round to the nearest integer, x squared equals 63. I'm going to solve this. Okay. If something is being squared, the inverse operation of something being squared is to take the square root. So I am going to take the square root of this. So I'm going to get x equals the square root, according to my calculator, of 63 is, it's not perfect. It's not perfect. But it's about 7.9, which would be about 8. Okay. The thing is, and we discussed this on number 20, is there any other number that might be able to be multiplied by itself to get a positive 63? And there is, and that is the opposite of positive 8, which is negative 8. So select all that apply. When we round it to the nearest integer, it will be positive and negative 8. Because both of those, when you multiply negative 8 times negative 8, you get positive 60. Well, you get positive 64, but it's close to positive 63. And the same with positive 8 there. Okay. 23. Solve the following equation. So if we have x squared equals 81, when we have something squared like I just discussed, we undo them by showing the square root. The square root of 81 is 9, but you can also take negative 9 times negative 9 to get positive 81 as well. So the solution here is going to be positive negative 9. Two more here. Again, 24, we're just going to take the square root of both of these. It does say round to the nearest tenth. So this is going to be positive or negative. About 15.6 6 when I round it to the nearest tenth. And it does tell me in the directions to round it to the nearest tenth, which is this first decimal point here. Okay, that would be 6/10. So make sure we are following those directions as we go through these. Number 25, the last one we have here. Solve the following equations. We are going to, it's only one equation, but that's okay. We are going to take the square root of both of these. It says round to the nearest integer. So we are going to have to round. That square root of 80 is close to the square root of 81, which is 9. So my guess is that it's going to be 8.9 something. So if it's rounded to the nearest integer, it's going to be about 9. Let me just check this in a calculator. The square root of 80 gets me, it's about 8.944. But it does say to the nearest integer, so it'll either be positive or negative 9. That wraps up this video, okay? Test tomorrow. Make sure if you have any last questions before we go or before we begin the test, you let me know. But yeah, good luck.